So, good morning, friends. Today, our topic of discussion is moving charges, moving charges, and magnetism. This is the topic what we are going to see today. So, the first part of the topic is that uh, uh, the space. The first one, what we're going to talk is that about magnetic field. What about this magnetic field? Magnetic field is the space in the surroundings, the space in the surroundings of a magnet, of a magnet, of a magnet, of a current, or you can think of uh, surroundings or magnet or a current carrying conductor, conductor in which the magnetic influence, the magnetic influence can be experienced, can be experienced, is called magnetic field. Magnetic field. That's how one can define the magnetic field. The next one is that the experiments of a scientist. You can make a note of this one, and you can pause the video and make a note. The next part is that it was the scientist O.E. Oersted experiments. He found out the when a current passes through a conductor generates magnetic field. This is what he has found from his experiments. So this is the part one of the chapter. This is the start of the chapter. Okay. The next thing is that we have Ampere's swimming rule. So this talks about how the compass needle gets deflected when it is near to a conductor. So for this we do something called snow principle. Snow. So if you remember the words, it's like so suppose let me keep the directions like this is my north, this is my south, and this is my east and this is my west. Suppose these are the directions. Now you remember this wordings now. So suppose I have the current is flowing from south, this is my south and this is my north. From south to north, suppose the current is flowing in this direction. So it says that you take a compass needle, you keep it near this our conductor. You keep this near our conductor. It says that the needle gets deflected towards the west direction. So it's like this. South. So S stands for south to north, and the W stands for west. And that means the compass needle deflects towards west. So that is deflects towards west. This is how you can remember. That's what the funda is. That this is the snow principle. So how the deflection of the compass will be. So I'll show it here. This is how the compass needle gets deflected. So this is the basic idea of the Ampere's swimming rule. So let's start with. So after this, we have the next one is that how the magnetic field is generated. When you have the next one is called Biot-Savart's law. It says that when you take any kind of conductor like this, and what you have to do is you just you have to consider a small piece of the conductor. It's called the element. A small piece of the conductor, let us say it's called element DL. And now you take any point P and the current is flowing like this through this conductor. So like this you can think of. And what you have to do is you just draw a tangent at this point. Okay, I hope you understood. This is how you draw the tangent. And from this point, the DL, you draw to the point of interest where we have to measure the magnetic field. So up to this point, you can just draw this. And now at this point, whatever the tangent you have drawn, the angle between the tangent and the line connecting the element and the point. So you have to take two things into consideration. First, I'll redraw this. So you have the conductor, you take one element, DL, and you draw a tangent at that point. So the element is a very minute thing, and you can draw the tangent to that at that particular point. And now you will measure the magnetic field at certain point P with respect to the element. What is the magnetic field because of this element? We have to see. And now you just join this point P. Okay, I will take this point here. The point P, you just join here, and this is my tangent. And you have to consider this angle theta. Assume that this angle theta. This is what we are talking about. And the magnetic field, what is the observations of that? The magnetic field is proportional to the current, and the magnetic field is proportional to the length of the element. So that is dl. And the magnetic field is proportional to the sine of the angle, whatever we have taken, this angle, the sine of the angle. And the magnetic field is inversely proportional to square of the distance, inversely proportional to square of the distance of the point P from the element. So this is what you have. And now the dB is, you can take, combining all the things, you get IDL sine theta by r squared. And now when you remove the proportionality, you get something called a proportionality constant. That is mu naught by 4 pi. That's a proportionality constant for you into I dl sine theta by r squared. And this is what is our Biot-Savart's law. Now the stuff is that what is mu naught by 4 pi? The value of mu naught by 4 pi will be 10 to the power of -7. So 10 power minus 7, you can have the units of Tesla meter per ampere. So Tesla meter per ampere. Those are the units of the mu naught by 4 pi. So this is the initial starting part of our uh, topic. So we will we'll meet in the next part of the topic.